Here's the quick way to simplify radicals when there's messy variables and exponents. So in the first example, we have the root of x to the 8th times y squared. The first thing I'm going to do is put a 2 that's missing right above the radical. Math gets lazy sometimes, and it's assumed that naked radicals are just square roots. Now what I do is look at the terms being multiplied inside the radical and see how many times 2 goes into each exponent to see what we can pull outside of the house. In this case, 2 goes into 8 4 times, so we're going to write x to the 4th on the outside. And 2 goes into 2 1 time, so we're going to write y to the 1st, or just y, on the outside. This gives us a final answer of x to the 4th times y, and you're done. Now let's make things harder with a cubed root and some trickier exponents. Here we're going to use the same strategy to see how many times 3 can go into each exponent. However, this time if there's a remainder, that means we have to leave it inside the house. Starting off with x to the 7th, we know 3 goes into 7 2 times, which means we can pull out an x squared. But because the remainder of 3 into 7 is 1, this means we have to leave an x to the 1 on the inside. Now for y to the 6th, 3 goes into 6 2 times with no remainder. So we pull a y squared out, and there's no y left inside. Finally, looking at z squared, 3 doesn't go into 2, so we can't pull any z's out, and the z squared has to stay inside the house. This gives us a final answer of x squared y squared times the cubed root of x z squared. But what happens if there's a regular number inside, such as this example? Here we're going to use the same strat, but need to write the 54 as something with powers of 3. Doing some simple math, we know 54 is the same thing as 2 times 27, and 27 is the same thing as 3 to the 3rd. Moving on, we do the same thing of seeing how many times 3 goes into each exponent. For the lonely 2, that's the same thing as 2 to the 1st, which 3 doesn't go into 1, so we leave the 2 on the inside. But 3 does go into 3 1 time, so now we can pull out a 3 to the 1st. Working on the rest of the variables, this is the same as the last example, which gives us 3x squared y squared times the cubed root of 2x z squared. And there you have it. That's how to simplify radicals when there are messy variables and exponents.
Nice!